Let's take a look at space weather for a few minutes, okay? Now, we talked about weather on Earth, how there's wind, and there are typhoons, and there are all kinds of things. Space weather is a little bit more simple, actually. Well, it seems very difficult, but it's actually pretty simple because the majority of space weather comes from stars. And what it is it is called solar wind. So solar means from a star, okay? And wind is kind of like on Earth, there's wind, but in space, the wind is different. Kind of different, not very different. They're kind of alike. Now, on Earth, wind is gases like air, oxygen that are getting pushed and blowing, right? In space, there's no oxygen, there's no air, right? So what is shooting? It's not air, but it's little particles. Particles means little pieces that are shooting out of the sun. And that could be light. It could also be other stuff. There's lots of stuff shooting out of stars at all times. And you can actually see in this picture that these are like clouds of dust and stuff in space. And it gets pushed by that solar wind, okay? So the energy from a star actually pushes things and can push this dust into these beautiful pictures and beautiful shapes, okay? So solar wind is what's coming out of a star, and it's energy and also little things, little bits of stuff, all kinds of stuff. We don't need to get into too much detail because that's really hard and I'm not a scientist, okay? So solar wind is all that energy coming out. Why does that matter to us? Well, that solar wind is energy coming from the sun, and then it can create something called aurora. Aurora. So this is a tricky word to say. The AU is like awe, kind of like in awesome, and then RO is ro, and then RA is ra. Aurora. Now, I know English R's can be hard to say, but what you do is you pull your tongue back and you go, almost like you're angry. Aurora. Try it with me. So, aurora is this cool light that is in the sky. And this is what the most exciting part of space weather that we can see here on Earth. This picture on the left is from a space station, and it took a picture. So that's what the aurora looks like from space. The picture on the right is what the aurora might look like from Earth, okay? Now, what is aurora? Well, it's that solar wind. It's that energy that is coming to Earth. Now, what exactly is aurora and how does it work? This is going to be scary looking, but be patient. It's not that scary. We won't get too much detail. Oh my God, science class. So, this is why we have aurora. So, let's take a look at this picture on the right. We're not going to talk about everything. Don't get scared. This thing in the middle, that's Earth, right? Now, these lines around the Earth, this is called the magnetic field. A magnetic field is like a magnet, okay? These two things here, these are two kinds of magnets. A magnet is a special kind of metal that can pull other stuff, right? Something special about the metal makes it so it has a magnetic field. And you can actually see the magnetic field in this top picture. It has this loop shape. Okay? So it's pulling energy towards it, pulling metal towards it. That's called a magnetic field. Field meaning that space around it. Okay? Did Kyle major in astronomy? No, I did not, but I really like space, and I just like to read about space. So when I was in high school, I would read science magazines for fun. Maybe I'm crazy, but okay. But this stuff, even though it's science, we're going to learn some words that are useful along the way, like magnet, magnetic field. A field is a place, right? So a magnetic field around the Earth is this, I can't see what color that is. Is that red? These lines around the Earth, that's called the magnetic field. Earth has it. Earth is a big magnet. And then this yellow, this is the solar wind. And you can see that the yellow solar wind follows the magnetic field and then comes down and hits the Earth. Okay? And what is happening? That energy from the sun comes down the magnetic field, hits the Earth, and whoosh, you get the aurora. So that's why the aurora is at the north and south of the Earth. If you're in Taiwan, we will never see aurora. It's in the middle here somewhere, right? But because of the shape of the magnetic field, the solar wind, that energy, hits the air on the Earth in the north and south. Pretty cool, right? And now this is very complicated. Don't worry about it. But because there's north and south, then we get two phrases that you should know. These are pretty common. Now it sounds really hard, but it's good English to know. This is called the Aurora Borealis. So there's that word again, aurora. Aurora means the lights in the sky. Borealis is a really hard word, Borealis. But what that means is that it's in the north. So that's the name of the aurora in the north. So the Aurora Borealis. And so another name for it is the Northern Lights. So maybe if you want to go to Norway or Finland or Iceland, somewhere in Northern Europe, you might see the Northern Lights. That's because the magnetic field of the Earth, the solar wind comes down, hits the air, and creates energy. Really cool, right? So the Northern Lights are beautiful, but if you understand why they're there, I think it's a lot even more awesome. Okay? So the Aurora Borealis, the Northern Lights, both names are totally okay. But if you ever want to go to one of these places, they might use this phrase, Aurora Borealis. Now, we just said that it hits the north and the south. The south has another name. In the south, it's called Aurora Australis. Again, a weird, tricky name, but you can see and hear where the name comes from. It almost looks like Australia, right? But it's actually Australis. And that's because Australia's in the south. Maybe you can see this in some places in Australia, okay? Now, Aurora Australis is a hard thing to say. Aurora Australis. I'm having trouble too. So, another name for this one is the Southern Lights. It's in the south of the Earth, so the Southern Lights. Pretty cool, right? And this picture, I couldn't find a picture from Earth, like someone taking a picture up. Most pictures of aurora Most of pictures of aurora are people in Northern Europe taking photos in like I said, Norway, Finland, Sweden, Iceland, those places. Aurora Australis, I'm not sure exactly where you can see them. But this picture was from the ISS, the International Space Station. And it's gorgeous, right? So this is from space looking down at the Earth. Really cool, right? And that's just energy from the sun following the magnetic field and boom, hitting the Earth. And when it hits the air, it creates light. Really cool. Okay. Monica says, I went to Tromsø in Norway to see the Northern Lights many years ago. It was a really amazing experience. Oh, I'm jealous. I've never seen the Northern Lights in person. I've seen pictures, but never been there. That sounds like an awesome experience. Thank you for sharing. Maybe you could tell us more about Tromsø. I'll have to look up where that is exactly in Norway. Probably pretty far north. You must have froze, right? But cool, thank you for sharing. So we have the Northern Lights, Aurora Borealis. We have the Southern Lights, Aurora Australis. Now that's really cool, but what's even cooler is Earth is not the only one. Boom! There is aurora on other planets too. This is super cool too, right? Or I think so. I get excited by this stuff. Every planet is like a big magnet. And so if you have a big magnet and you have solar wind, you get aurora. And so here on the left is a picture of Jupiter. And you can see in the north, there's the aurora on the North Pole. Just like Earth, the magnetic field is like a bubble. So the solar wind goes to the north and south. Pretty cool, right? And then on the right, we have Saturn, the second biggest planet. And here you can see some pictures where the aurora is in the north and the south. And this picture on the right, these are real photos, by the way. This is real. The photo on the right was taken by Voyager, I believe. Voyager was a spaceship that flew out into space. And they were able to get a picture of the north and southern aurora at the same time. Super cool, right? Yeah. So other planets get aurora too. It's really neat. Okay. Let's keep on moving. So aurora is one thing about space weather. I almost said solar weather. Space weather. Another thing that is a little bit, this is a little more tricky, but interesting and maybe a little bit scary, is something called a coronal mass ejection. Okay, this is scary vocab, but don't worry about it. Slow down. Take it piece by piece. This is the sun, right? The sun has many different parts. One part is called the corona. Corona, just like the beer, Corona, and coronavirus, corona means a crown. So it's about the shape. The sun is this circle. The corona is almost like a crown that's around the sun. It's this energy, this stuff around the sun. And so the corona is around the sun. So we turn it into an adjective, coronal mass ejection. Now let's do piece by piece. The corona is out here. A mass means like a big piece of something or something big, huge. And it's a mass, blah, blah, blah. And then ejection. Eject, you can see the word eject in here, right? Eject means to shoot something out, okay? If you have a CD player, you push a button to eject the CD. If you have a airplane, like a jet, there might be an eject button and the pilot shoots into the sky and their parachute opens. That's eject. So ejection means shooting something out. A mass ejection means shooting out something that's really big. Coronal mass ejection, shooting out something really big from the corona of the sun. And you can see this picture, this big piece of sun shooting out. And that's really crazy and cool, but actually it could be dangerous. So this thing, a CME, could mess up electricity. Maybe we would lose power or lose lights if a CME hit Earth. So it's kind of like almost like a typhoon coming from the sun. We were talking about space weather, right? If we had this, a CME, we might lose electricity here on Earth. So it's a little bit scary, but pretty cool looking and interesting. The picture on the right is not real, of course. The picture on the left is a real photo that NASA took. It's pretty cool, right? Crazy stuff. And this is huge. Now, let's take a look at what does a CME look like when it happens. Ready? Okay. So, here in the middle, we have the sun, of course, the surface of the sun. On the outside is this orange glow. It's almost like a crown, right? So it's like a crown, so we call it a corona, okay? Or the corona of the sun. And you can notice these CMEs are these things that are shooting out. The magnetic field of the sun creates these loops, and sometimes the loops will shoot out, and it shoots out a mass of stuff. And it's really cool looking, but it could be bad weather for the Earth, right? 太阳风暴. I'm actually not sure what the Chinese name for this is. Let's see. Let me look it up quick. Coronal mass ejection. Oh wait, I should show you guys how I do this anyways. We've talked about how do you find things. Do you use Google Translate? No, don't use Google Translate, use Wikipedia. So you find the thing you want to know here, coronal mass ejection. And so you type the thing into Wikipedia, and then what do? Go down here on the left, languages, and then you hit 中文, Chinese. And then you get the Chinese name of this. Oh my gosh, I don't know how to read this. Well, this part is the sun, the corona. This part is mass, the stuff. And this is ejection, shooting it out, okay? So a coronal mass ejection. I don't know this word, and this one I'm not sure about either. But maybe that's why I didn't do so well on my test last week. But anyways, Wikipedia is your best translation tool, I think, especially for very difficult things, okay? Okay, so yeah, CME, coronal mass ejection, is this kind of crazy thing. It's really cool. Go read more. It's interesting. Now, that's pretty much it for our space weather today. But one more thing before we go is I want you to be brave when it comes to science. When it's science English, it can be really scary and difficult, but it's really cool. And you can try reading articles like this. This was in the news today, so I decided to mention it. So it says, Neptune and its rings come into focus with the Webb telescope. So the Webb telescope is this brand new telescope that is taking all of these beautiful photos. And if you learn a little bit of science English, you can try to read an article like this. So this is Neptune, one of the planets out in space. And here on the right, these are the two new pictures of Neptune. And they were photos taken in infrared. Infrared means taking not real light, but using heat and temperature to see it. So got this really beautiful photo of Saturn, not Saturn. It looks like Saturn because of the rings, but it's actually Neptune, this blue one. We can't see the rings easily, they're really small, but in infrared, when we look at the temperature, you can see these rings. Really cool. So this is the thing about science words, science English. It's really difficult. Something like coronal mass ejection. But you can look at it piece by piece and you can figure out the word. Okay, I know eject, so ejection must be shooting something out. A mass, sometimes mass talks about how heavy something is, so maybe it's a thing. And then coronal, corona, I'm not really sure what that is. You could Google it, find out it's like a crown or this thing on the sun. So even if you see difficult English or science English, don't be scared because it's cool, interesting stuff. And you have more interesting stuff to talk about, right? If you see this news and you share it with your friends or family, that's a fun thing to learn about. Oh, did you see that new picture of Neptune? And your friend is like, I don't know. And then you can share and tell them about it. And it's pretty fun, right? So I think this stuff is pretty cool, interesting. It's technical. It's a little bit tricky, but it's all fun and interesting, and also helps you to figure out how to deconstruct English. What I mean is, deconstruct means you have something difficult and you take it apart piece by piece. And that's something that I want you guys to practice and try to get comfortable with. If you see a long, difficult word, don't say, oh, I don't know that word, I give up. Or don't just Google it. Don't use Google Translate. Try to look at that big word or that big phrase and think about it piece by piece. And that's a really useful skill for language, especially for English, where you can push words together to make new words or bigger words, okay? So, yeah, I hope you guys had fun today. I hope you thought this was interesting. I love learning about space, so I could talk about it for a long time. You guys probably are falling asleep now. Oh, it's too much space, too much science. But if you take it piece by piece, think about it in simple ways, it's not that hard, actually, I think. Or I think it can be really fun and cool and interesting. So, yeah, that's it for our space weather talk today. If you guys have any other questions, leave a comment on our in our group or on this video or wherever, or send me a message asking me a question if you want. Well, you could find out a lot of things by yourself, of course, but if you want ideas of where to learn about this kind of stuff, you can ask me. I think it's a lot of fun and pretty cool. Let's stop here for today. Thank you everyone for joining. I hope you had a good time. Stay safe. Stay healthy. Good night, everyone. Bye-bye.